Hello, friends. I would like to welcome all of you to this month's webinar, 7 micrometrics that predict production outages in Performance Lab. And I'm Ram Lakshmanan. So I'm the architect of Ycrash Product Suite. So we will get started. Okay. Yes. So friends, whenever there is a production performance problem, so whenever there is a performance problem that happens in production, our management asks this question. Right? This is their favorite question. They always ask, why didn't performance tests catch this problem? Has anyone faced this question from the management? Has anyone faced it? You can put your comments or chat, right? So this is one of the common questions our management asks. Why this problem was not caught in the performance lab? We are doing tests. Why this is not getting caught, right? This is something we always confront. And we performance engineers, we give this as our answer, right? Our typical response goes like this. We say the production data is different, whereas what we have in the test bed, the data is different. So the data plays a very important role, and we don't have the identical data. And another response that we give to this question is, see, it's very hard to simulate a production traffic pattern, production traffic mix in our performance lab, right? It's very hard to replicate that traffic here. We are evolving, right? Some of us are recording and replaying, right? We are evolving, but it's not identical yet. And the another response that what we give is the production environment and performance environment is not identical. It's always different. It's not exactly replica or mirroring it. Because of all these three reasons, we are not able to we are not able to replicate this performance problem that happened in production. It's not happening in the performance lab. All are very valid points. 100% agree. There's no question in that, right? I totally with you. But my friends, I want to share with you an reality here. Production performance problem do happen in our performance lab. I can say with all confidence that it do happen in our performance lab. But it happens at an acute scale. That is, let's say if there's a memory leak is happening in production, in performance lab, we see arbitrations. We do see the memory fluctuations. But they do happen at an acute scale because of these earlier reasons, because the production data is different, the traffic volume is different, and the environment is not identical. So it doesn't happen at the same scale that it happens in the production, but it does happen in our performance lab as well. But it happens at a small scale, at an acute scale. So it's not big enough to catch our attention in a performance lab. Because in our performance lab, we only monitor macro metrics. Primarily, right? Most of us, we only monitor the macro metrics in our performance lab. What are the metrics we look in our performance lab? We look at the response time. What is the average response time? Or the 90 percentile of it, of the key transactions. What is the memory utilization? And what is the CPU utilization? So these are the primary macro metrics that we do observe, and that's what we compare with the baseline and the new release, which is going live. And then we certify the releases. See, these macro metrics are great metrics, which is something we need to continue to look, and we should be looking. But along with that, in this session, I'm going to be sharing with you 7 micrometrics. These are micrometrics. These metrics can predict the production problems. Even if it happens at an acute scale, even if those problems happen at acute scale, these micrometrics is going to bring it to our visibility. So I'm going to be in this webinar, I'm going to be sharing with you what are those 7 micrometrics that what you want to be monitoring. And then I'm going to be talking about how you can source these micrometrics, from where you can gather these micrometrics. First part, I'll just talk about what are those metrics. Next part, I'm going to be talking about how you are going to source these metrics. Okay, let's keep moving. Friends, the first metric micrometric that what I want to share with you guys is the garbage collection behavioral pattern. That is, we need to study how the garbage collection is behaving in the performance lab. We need to study the garbage collection behavior, right? So, friends, this is the garbage collection behavior of a very healthy application. Why do I say very healthy application? Look at this, what's happening. The, the request is coming, the memory is building up. When this full garbage collection event ran, the memory dropped all the way to the bottom. You can see a steep fall. And then once again, the request is coming, the memory is building up. When a full garbage collection event ran, the memory is dropping all the way to the bottom. Friends, I see some people raising hands. If you have any questions, always put it in the chat or put in the Q&A session. I will answer them towards the end of this session. Okay. Okay. So you can see the request is coming, the memory is building up. When this full garbage collection event ran, the memory is dropping all the way to this bottom. You can see there is a beautiful sawtooth pattern. It's going, memory is building up, and the garbage collection runs, it drops straight, steep fall. You see this beautiful sawtooth pattern. If I try to put a line connecting all the bottom points, it's the black dotted arrow line. It goes almost at a 0 degrees. You can see it's almost going to 0 degrees. Okay. Now, friends, look at this pattern. Look at this GC behavioral pattern. See, if your application is suffering from, say, how does a GC behavior pattern looks when the application is suffering from an out of memory error in production? Say in production, you're getting out of memory error, right? How does that GC behavior looks in production? You can see the memory is going up when the garbage collection and memory is dropping. You can see it is dropping. After a point, look at this, friends, towards this right side where my mouse cursor is there. You can see the garbage collection is keep on running. The memory is not coming down at all, right? And we strike out of memory error when we hit this ceiling limit. When you hit the ceiling limit, you're going to get out of memory error. Friends, in our performance lab, if you're observing the garbage collection behavior pattern, you will start to see this kind of a trend. Look at this. You can see it is going up, down, up, down, up, down, up, down. How long do we run our performance tests? Our performances typically, it varies from organization to organization, but based on my talking with fellow engineers, we run for 1 hour or we run it for 2 hours. In that window, you can see the memory is building up. Memory is not going down. But then our test concludes within 1 hour or 2 hours. If we let it run, with the production traffic, with the production data, when it's going to manifest. It's going to start building up like this, and you're going to get out of memory error. So if we start to look at garbage collection behavior pattern, and if we see this kind of behaviors, that means we want to flag it as an error. We want to report it saying, performance lab, we are not going to certify this release because we see the memory is keep on building up. It is not going like this. If this means we can certify it, it's going like this. And if it's going to continue to run, when with the real actual production data, with the real action production mix of traffic, it's going to become like this. We want to raise a flag, right? So observing the garbage collection behavior is one micrometric, what we want to look. Okay. So now let's move on to the second micrometric, which is the object creation rate, right? Friends, one of the metric that we observe in our performance lab is what is memory utilization. See, if I'm going to set my memory utilization, XMX, right? My heap size, XMX as 6 GB or 10 GB, it's going to be remaining within that limit. It's going to be like 6 GB, 10 GB. That's what I'm going to be looking at. I'm going to be seeing. But if we focus on this object creation rate is reported like this. Is reported. Basically, it just says, this metric says, what is the amount of objects created in a unit of time? So it says 100 megabytes per second, right? This is how it's reported. My application is creating 100 megabytes per second. What if in your previous release, you are creating 100 megabytes per second? In the new release, which is going to go live, what if you're creating 200 megabytes per second? We are not looking at this metric today. What if what if it's happening? You are now creating 2x more objects for the same workload. See, our performance test, right? What are the transactions we send remains same across releases. And now in the new release, if we start to see 2x more objects created, that means what it's telling? It's telling me some inefficient code the developer has committed into this new release, due to which to service the same workload, more number of objects are getting created. So this is going to manifest as high CPU consumption and degraded response time in production. So, right, because now some inefficiency has gone in, or maybe it could be possible that developer has created some new feature, and that new feature needs more memory, but at least it needs to be discussed when we submit our performance report. We need to bring it to the development team visibility. Hello, developers. Last release, you're only creating 100 megabytes. Why you are creating 200 megabytes per second? What has gone wrong? We want to flag it. We want to question them. So maybe then they will say, oh, no, I introduced some new algorithm. Or they may say, oh, okay, I'm doing the things a little bit inefficiently. And then they can go and arrest it. So rather than this becoming a production problem, we can catch it in the performance test during a test time frame itself. Okay. So the next metric, see, along with that object creation rate, there are also metrics which can say, for this workload, what is the total bytes I have created? Okay, for this workload, in this new release, I'm creating probably 48 gigabytes of data. 48 gigabytes of objects I created in memory. In the previous release, maybe I was just creating only 24 gigabytes. Right? So we want to bring this metrics and then we want other discussion with the development counterparts. Okay. The third metric, what we want to bring and what we want to bring it to the table is the garbage collection throughput. Friends, what is a garbage collection throughput? Friends, when garbage collection runs, it stops your JVM. It pauses your JVM so that no customer transactions will be processed. For the garbage collector to work, it pauses your JVM. So GC throughput tells cumulatively how much time your JVM is paused for doing garbage collection. Like say this metric is reported in percentage. Say for example, if we say your garbage collection throughput is 99%, it means 99% is spent in processing the 99% of the time is spent in processing the customer transaction, and remaining 1% of time is spent in processing the garbage collection activity. Right? 1% of time you're spending in doing the garbage collection activity. Friends, what if in the previous release your throughput was 99%, and in a new release it is 96%? That means there's a degradation has happened. That means your application is spending more time in garbage collection. If your application is spending more time in garbage collection, that means it's indicating that either there is some high object allocations are happening in the new code, or there are some GC settings or JVM settings has been tweaked by your engineering team. So we want to get to our visibility. We want to see what is happening with GC throughput, whether it is worsening or it's degrading or it's getting better. So we want to look into this metric. And if it's worsening, we want to find the root cause of it. Because the reduction in garbage collection throughput will result as reduction in your response time. Your response time will start to go down, right? Because if your application spends more time in garbage collection, more time it pauses your application. If it pauses more time, it takes more time for garbage collection. That means any customer transaction that is going to come, their response time is going to degrade. So looking at this metric is an early indicator that a response time is going to degrade. Okay. This is the third metric that I wanted to bring up to your visibility. All right. Okay. The fourth metric is the thread patterns. See, friends, threads are like kind of a blood system of the application, right? See, friends, say if I go to my doctor's office, for any diagnosis, he draws my blood samples. If any of my body part has any problem, let it be my heart, liver, kidney, anything, it will be reflected in your bloods, in your blood samples. So that's why they take the blood samples. Similarly, if there is any arbitrations or if there is any performance problem anywhere in your application. Let it be with your backend system, or let it be in your code base, let it be in your memory, let it be in your operating system, anywhere, it will be reflected in the threads. 100% it will be reflected in the threads. So if you can study the thread patterns in between the releases, that will act as a very early indicator of the problems that is going to come in production. See, for this, I want to share with you a real case study, a real world case study, which happened in production environment. So this problem happened in production environment. Look, this is what was happening in the production environment. Look at this, my friends. So this enterprise, they went live on Friday evening. On Friday evening, once the peak traffic volume settled on the week, on Friday evening, they made a new release. Look, once they made the new release on October 8th evening, you can see the CPU, which was flat, is now starting to show, is starting to wobble and starting to go high. On Monday morning, as traffic starts to come, you can see it's starting to go high. At the same time, look at this, the number of database connections is also starting to go high. And then the application couldn't take traffic, application was crashing, alerts were getting generated. This is what was observed. You can see this is what was getting observed. Friends, this team, they capture thread dumps as part of their performance test. Now, when we looked into the thread dumps, right? See, when we look into the thread dumps, the thread dump, the analysis, it was reporting. See, the 20 threads are getting stuck, waiting for response from this, a thread dump analysis report. We will see how to source these metrics towards the end of this session. So here it is reported, the 20 threads were stuck, waiting for response from external system. Only 20 threads were stuck. It was not big enough to come to the visibility in the performance lab, but it was reported in the thread dump. So here is a stack trace. You can see these were the 20 threads which were getting stuck. So these threads were getting stuck when they're going through this MySQL call, right? It's MySQL database it was going, and it was getting stuck. And it was originating from this particular line of code, from this data access object. So it was originating from here. So what had happened? Then when performance team, when they looked at it, when they asked, oh, what's going on in this method? Select report by ID. What is going on here? Then the developer was saying, oh, I made a change to the SQL query. The SQL query I modified. So because of his modification, he was not doing proper joins. Earlier, the SQL query was completing within in milliseconds. Now it was taking like a 50, 60 seconds to complete. Every call was taking very, very long time. But since in the production, for the 3 reasons that we told, it was not big enough. It didn't show up in the performance lab. But once it go to production, it came to the visibility. But if the team would have done the thread dump analysis proactively, they would have caught it. This problem could have been avoided in the production environment. Okay. So now I'm moving on. The fifth point, that fifth metric that I want to share with you is, friends, look into the thread count and the states, the thread states, what they are. The thread has different thread states, and look into the count. So here is a thing, a report. I'll tell you how to source all these metrics. It shows how many threads are there and in what states they are, whether it's a timed waiting, runnable, blocked, what states they are. See, friends, sometimes your threads can have a leak. Your threads can leak, right? Because let's say, because of some poor programming, you will start to developers may create more threads than what is needed, right? But these, we don't look into these thread count. But when thread starts to build up, as time starts to go, if thread starts to build up, then your application will suffer from unresponsiveness. But the thread buildup will be visible in the performance lab, but it will not be big enough to tip the thresholds. It will not be big enough to become application to become totally unresponsive, or the memory to climb so big. But you will see the variation. Let's say in the previous release, If this application, your application was having only 400 threads, and now it is having like 2,770 threads, 5x increase. It's a clear indication there's something gone wrong in this new release. So we want to flag it and we want to report it. And then also not only that, within our application, within all our applications, we do a multiple internal thread pools. So if you're running on a Tomcat has a Tomcat thread pool. We have a scheduled jobs to execute scheduled job. We may have a quartz a scheduler thread pool. We may have a separate thread pool for making backend calls. So we want to see what are all the thread pools which is there in the application and what is the count of threads in between the previous release and this release. And what is their states? Okay, here we see that there is a thread pool for this application called default IO. It is having 2,400 threads. Maybe in the earlier release, it is having only 800 threads or 1,200 threads. Why there is an increase? And you can see all of them are in a runnable state. Why they are? So we want to question these things in our performance lab so that we can mitigate a major outage that's going to happen in production. Okay. Friends, the sixth metric that what I want to share is TCP/IP connection count and the states. See, these are all the things that we often ignore, but they are very vital to look at it. See, what if in your new release, a developer has introduced too many backend calls to external system? Let's say he has now introduced more backend calls. Or what if he misses to close a connection? Failing to close a database connection is one of the common performance problem. Developers, because we make multiple calls, even if a developer misses to close a connection, a database connection or a network connection, then those connections will start to build up. It is building up in the performance lab, but it's not big enough to cause an outage. So if I'm going to start to study the TCP/IP connections, what are all the OS to which my application is connecting, and what is the connection count, and in what TCP/IP states they are, then I will get to see, right? Say, for example, here is a visualization of TCP/IP connections and the states. So here there is for this host, 23 connections are being made, and 18 are in established state and 5 are in closed wait state. Friends, if your developer misses to close the connection, then what's going to happen is you are going to see a lot of connections build up in the closed wait state. You'll see it start to build up, closed wait state. It's going to start to go high. Maybe if you can compare, for this host in the previous release, I didn't have this many connections. Then that means maybe your developer is opening too many connections. But let's say the connection count is identical, but if you see a lot of closed wait connections, that means the indication your developer is not closing the connection. So then we can flag it. We can flag the release. And now look at this. So when I'm going to start to look into the TCP/IP connection states and the count, if there are any connection leaks, it's going to bring to my visibility. If there are a lot of chattiness in between your application and your backend system, it is growing, then it's going to bring to my visibility. And if the developer is not closing the connections and the connections remains idle, it's going to bring to my visibility. All these network related issues we can catch if you're starting to look at the TCP/IP connection states and the count. Okay, friends, and the seventh one is the error trends in the application log. Friends, application log is a kind of a gold mine, but also it's kind of a kitchen sink as well, right? Developers dump so much information into it. So in performance lab, typically we don't look. The application logs are only looked upon in production when some problem happens. That's when we get the data and when we look. What if we start to proactively look in our performance lab? And especially, I want to look at number of errors and the types of errors that is getting reported in the application log. Like say, for example, here is an example. It shows all the errors that has occurred in my application log. I can see, there is this null pointer exception with this track trace. 100 of them has occurred. And here now I'm seeing index out of bound exception, 180 has happened. What if now in the new release, I'm starting to see a different type of errors, which was never before the case. So I'm starting to see new type of errors. Or if I start to see increasing in the number of exceptions, number of errors, then maybe there is some functional problem or a performance problem there. And developers, they themselves will not know because no developer looks into application log until it's a production problem. So if we can start to look at what are the errors that is happening in the application, then it may bring some new problems that is brewing in the application to visibility, right? So friends, these are the 7 primary metrics that I wanted to share with you, right? There are more metrics, but these are the primary metrics that we want to share. And friend, these metrics, if we can supplement these micro metrics along with the macro metrics that we are reporting to the development team, your performance report is going to become more comprehensive, more thorough, and we might be able to answer to the management question. Yes, these problems were flagged in our performance lab. We can answer it, right? Okay. So now let's move on. Let's discuss how to source these micrometrics, from where I can source these micrometrics, right? So friends, for this, there is an open source script called as this YC data script. So this script, it's an open source script. It's available in GitHub, no licensing, nothing. You're welcome to use. It's just a simple script. It can run on all flavors of Linux, Windows, Mac. So you need to trigger the script like this, YC -P, and then the process ID, your Java process ID, which on which you're conducting your test. So when you trigger it, this script is going to capture your 360-degree data from your application stack. It's going to capture the garbage collection log, thread dump, heap substitute, network data, application log. It's capturing the network data, all the data that we discussed earlier, it's going to capture. And then it's going to capture, and then it has 2 options. It can bundle them up as a zip file. All these 360 artifacts can be bundled them as zip file and then given to you. Now you can take the zip file and then you can analyze them manually and then get these metrics. Or this script is open source, but there is a commercial version. There is a commercial tool which can analyze these artifacts. So that's where this ycrash tool comes into picture. So you can configure the script to transmit this 360-degree data to the ycrash tool. So the ycrash tool will analyze this 360-degree data and then create an incident report for you here in the dashboard. So this is how it's going to create an incident report in the dashboard. Now let's look into one of the report. So now all these incidents have been created. Let's look into one of the report here. Okay, so now this gives me a 360-degree analysis report. What's going on? See, the first metric that what we told we want to source is if any garbage collection behavior, right? Here is my garbage collection behavior that's happening. The tool will analyze the garbage collection behavior, and if there are any flags, there's acute memory leak is happening, or there's any consecutive full GC patterns are happening, or those kind of things, it can detect and report it as the warnings and the flag. So this is something you can take and see how it was before and now, if there are any new errors are showing it. And then what are the other metrics? So I want to look at my GC throughput. What is my GC pause time? What is my object creation rate? All these metrics are available. And then the next one is, what is my threads behavioral pattern? Or how many threads are here? And what states they are? Right here is those thread pools and what state they are. And if there are any threading issues, like the threads are getting stuck and not getting released, it will be flagged as an error for you. And now if you want to look at the network report, that is what are the TCP/IP connections and what states they are, here it is reported. And then if you want to look into your application log errors, whether there's a change in the trends that is happening, it's going to be reported here. Okay, these are all the errors. This is the count and what, so we can present it, right? So here I have just put a table saying these are the 7 metrics from where all you can source this metric from the ycrash incident report. Yes, that's what is presented to you. Okay, friends, I want to share with you a best practice, right? When to capture these micrometrics, right? See, friends, say suppose you're running your performance test for a 1 hour window. You want to capture 2 snapshots of these micrometrics. That is, you want to trigger that YC script 2 times. One at the middle of the test, so that you can see how the traffic is going, and one towards the end of the test. Once the test is completed, at that point also we want to trigger, then we want to see. And then we want to take these metrics and then present it in our report. And if there are any anomalies, then we can flag it as an error. Okay. So, friends, I'm going to be answering the question, but in case if you are not bored with this webinar, and if you want to learn more about JVM performance engineering and troubleshooting, I'm offering an online JVM performance troubleshooting and engineering masterclass. It's available online. It's a recorded program. You can watch it at your convenience. So it is available online. You can take a look at it. Okay. So, friends, thank you everyone for attending this session. I'm going to be here taking the questions. What are the questions come? I'm going to be answering from this point. But whoever wants to leave, you are welcome to leave. But thank you everyone for attending this month's webinar. We will connect with you once again next month's webinar. Thank you, friends.